All right, so today we're going to be taking a look at scope and extent. And this is a little bit more of a complex idea, so I'm adding a bunch of notes here on my Common Lisp the language text, and I'll go over them as well with you, and let's see if we can get some decent understanding of this. So scope refers to the spatial or textual region of the program within which references may occur. Okay, so that's the area, basically your code blocks. Okay, that's your scope. Okay, so one scope is a code block, and another code block, and another code block. Those are basically scope. Extent refers to the interval of time during which references may occur. So, okay, so that means to say that the extent basically is the lifetime of an object, right? So we have an object that's created in one scope, and that extent may go through a number of other scopes, right? And at some point it ends, right? Either in a scope or in, actually, it can even be in no scope, so to speak. It could just be floating out there until the GC comes along and zaps it out of existence. But for the most part, the extent, the life of an object basically has a length of time that it exists. And of course, the scope is the life of a name. So you have the life of a name. So this is when whatever name you give to refer to this extent, right? That's called a binding between a name and an object. Referred to as a value, but this is basically it's a synonym for object here for the most part. So basically, again, so you have a scope. This is where basically you have names, right, in your code block that are referring to some object or many objects, right? So each one of these objects has its life, right, which is not necessarily the same as the scope, right? And we're going to talk about that in a little bit. Okay, so the scope of the parameter named x is the body of the defun form. So basically, we have our function over here. So x, its scope starts here and ends here. What's pretty cool by Lisp is we have these beautiful, wonderful, unbelievable parentheses. Beautiful parentheses are beautiful. So anyways, you have these parentheses, and they pretty much make it clear for us that we have a scope between parentheses, right? So basically that scope between those parentheses, right, he says that basically is where x exists. Okay, now we'll talk about what happens if you have x existed in another set of parentheses outside of this, but we'll get there when we get there. Okay, the scope of the parameter named x is the body of the defun form, right? That's where it exists, right? Okay, so therefore the extent of the parameter x, right? Because again, this is an object, right, as well. For any time you call copy cell, there is the x, the name, and then there's going to be the extent of the parameter existence, right? So the extent of the parameter, all right, if it could potentially, right, last beyond the time of the function edit. For example, I could return x out to the world, right? Whatever object x represented here, I could then feed it out to the world basically at the end. So it can come in and it can then extend beyond, right? Okay, so the extent of the parameter, so again, one more time. So similarly, the extent of the parameter x, right, for any call to copy cell, is the interval from the time the function is invoked to the time it is exited, right? So that's the entire, right, that's the entire extent of the parameter x. And in the general case, the extent of a parameter may last beyond the time of the function exit, right? But in this particular case, that may not be so, but nevertheless, as it points out there, he says this x, of course, can be, again, stored someplace else and exists in an entirely different part of your system. So again, now we'll explain what that means and the names we give to these existences in a little bit, right? But just remember what we said here. Scope is the lifetime of a name. The extent is the lifetime of an object, right? So an object could have started before. It can continue to exist, referred, right, to by different names. I mean, we can bind a name to an object, and right, name to an object, and we can make use of it then in the code block once they've been bound, right? But these objects are floating around in the, in sort of this external space. They exist. And there's many other objects, for example, that may exist in various different hashes and globals and all kinds of things. Whether they have a existence in your particular scope of code, right? Depends if we bound out to them. Okay. So a binding is a name referring to an object, right? That's a good way to remember that, okay? So let's look over here now. Okay, so what happens is like this. So we talked about now this concept of scope. Now that we understand a little bit about what extent and scope is. So lexical scope, right? Lexical scope says, right, that everything basically contained textually, right, contained within the establishing construct, meaning it exists within a code block, right? That's called the lexical scope. Okay, so the lexical scope is a code block. Indefinite scope, right, that basically says that it exists not within the framework, basically, and that's not between two parentheses. So if I go ahead and I create a global parameter, a def param, I create the parameter, I create a def var, right? I go ahead now and I've created an object that's now floating around, right, in that space, and it has an indefinite scope, right? It can exist at any time, at any place, right? It's not like it's going to go out of scope. It's not going to lose, we're going to lose access to it, right? So basically, just remember, lexical scope is a scope local to a code block, and infinite scope is global scope, right? That's pretty much sort of a translation. But lexical scope, like I said, is within those parentheses. Infinite scope is outside those parentheses. All right. So that's what scope is, right? Again, scope. All right, so scope basically, like I said, that's our code block, and extent of the object could be more. So now when we get to the next piece here, we're going to talk about extent, right? So dynamic extent, right? Dynamic extent, and to make it easy, just imagine this. Something which exists in a lexical scope, right? I mean, within those parentheses, right? And it ceases to exist at the end of the parentheses. That's called dynamic extent, right? So again, something where, if we look back to our piece over here, if this blue line started here and the blue line ended here, right? It went from here to here. That's called dynamic extent. I know it sounds kind of weird. I'd almost kind of like say, like, why wasn't it called like static extent, right? Because it's going to exist and it's going to disappear only within our lexical scope. But basically, that's called in Lisp dynamic extent, right? So that's dynamic extent. So just remember, if this basically the scope where it was created equals the extent of the object, right? That's meaning the red and the blue are the same. Then that is called dynamic extent. And basically what that is, for people who have some familiarity with other languages, is that's the equivalent of a stack allocated object. Now, in fact, because what happens, it starts to exist on the stack as part of your function, for example. And when you get to the end of the function unravels and unwinds, right? And everything that was in the memory space that existed of that lexical scope that we had there, right? So all the dynamic extent objects just disappear, right? So it's a very, very fast way to allocate and deallocate, and fairly safe as far as memory concerns and things like that. The GC, the garbage, the garbage collector doesn't really have to deal with it, right? It just goes in and out, boom. It's very simple, right? So basically, something of dynamic extent, right? Basically, that's what the case. So you mentioned dynamic extent. Obey a stack-like discipline, paralleling the nested executions. We'll actually talk a little bit more afterwards about dynamic extent in a moment, and of an interesting effect that it has as well on your code. But for the most part, just remember, dynamic extent are basically stack objects, and they're things that only exist in the same area as lexical scope. So again, remember, lexical scope, right? That's what we had before. Lexical scope, that red line again and the blue line are the same height. Okay, so infinite extent, right? Infinite extent, right? So basically, this is a situation, scope, where created, that should be there, right? Does not equal the extent of object. So basically, what that means is, if you remember over here, the red and the blue don't match. So this would be an infinite scope object, right? That basically, here's our lexical scope, and here's our infinite extent. Sorry, infinite scope, infinite extent right? Infinite extent. So dynamic extent and infinite extent. Okay? Okay, so again, now, practically speaking, most objects in common lists are actually going to be infinite extent, right? That's because of the fact that you're going to create an object and you're going to pass it out, for example, from a function, and it's then that same object, which now is going to have a new binding in a different scope, or how it be, meaning it's going to have a different name referring to it, perhaps, or other things, but basically that object will continue to live on beyond your function. So that you might think of that as having an infinite extent of existence. The dynamic extent, right, basically only exists within, again, a certain period of time from the beginning to the end, right, of a particular scope. Now, and one of the things I didn't mention before is that the scope, right, something which is created in any scope, for example, and then escapes the scope because the extent of the object is that blue line that goes beyond, so that is generally a heap allocated object. So like in C, for example, you do a new, and that would create your heap object, and then it would have this existence, and when there's nothing referring, there's no bindings, nobody needs the information anymore, what happens is it sits and floats until the garbage collector comes along and zaps that out of existence, right? So that's basically, so infinite extent are objects that essentially are floating in the ether, right? Again, waiting to be either used or bound to be used, or it basically to be zapped out of existence by the garbage collector. Okay, so let's talk about one other subject before we get to one other fact about this, okay? And that is, right, we'll skip back to that. It's something called shadowing, and there's a reason why we'll skip back, and I'll show you that in a moment. So in the case of lexical scope, right, if, for example, you have two constructs that establish entities with the same name and are textually nested, the inner one shadows the outer one. So, for example, in this example, right, the z is bound to the result of x times 2, right? So x comes in here, there's a z that came in, so the x times 2, whatever that might be, let's say 5, so now it's 10, z now is bound to the number 10, print z is going to say 10. But what happens if z here was a 3? So the z is shadowed, you don't see the z, but what happens when we're out of the lexical scope created by the let? Then we go back into the scope of the function, and then we see z, we see the result of that. So what happens is that z will print 3 here, and over here it's going to print 10. Right? So that's what's going on over here. Okay? So that's the idea of shadowing. Right? So you have a function. Right? Very simple. Now, let's go back for a moment. Okay? And with the case, there's something else called dynamic scope. Right? And that's a name given to a case where you have indefinite scope, meaning you have something, right, that, in other words, that basically can exist anywhere. It's a global, right, and it has dynamic extent. Okay, so that's the case. So now, this dynamic scope idea is, so you have an object basically which was created globally, right, and that object, right, that object basically also has a dynamic extent, right? So that means to say that, again, that the object is going to basically exist in the confines of your particular software from beginning to end. So beginning is created globally. So basically it just means essentially a global that exists from the time this program starts to the time the program ends. But this particular interesting idea is that you actually end up with something neat. And we can call these special variables because of this. All right, so let me show you what's special about them, right? Okay, so take a look over here, right? So I'm going to create a dynamic extent and an indefinite, all right, right, definite, oops. Something weird. All right, so dynamic extent and indefinite scope, right? That's the case here. That's this. In fact, we traditionally write these earmuffs, the little stars back and forth, asterisks, the beginning and the end. And in fact, the actual compiler SPCL will identify the earmuffs and actually, we'll remember that, oh, this must be one of these dynamic extent indefinite scope objects, meaning to say it's a global object, right? That's going to have this property I'm going to show you in a moment. That makes it special. That makes it part of the dynamic scope. All right, and to see that, we make a function, right, that will just display our special variable g. So I'm making now something to test this. So test me. We'll go ahead. Let's see what we defined it here. We gave it right of 10. So show me, right? So show me what I have going on in my special variable, and it's going to equal 10. And then I'm going to go ahead and create a local scope, right? A lexical scope of this let here, right? That in that place, I'm going to go ahead now, and I'm going to create. I'm basically going to bind again, right? Then we're going to bind again the same global, right? That same dynamic scope object, that same special variable a second time. Now, in a sense, you might say, I'm going to shadow it, just like we talked about before, shadowing by the lexical scope. Actually, in this dynamic scope, shadowing also kind of works, except there's one neat thing. It shadows it on the entire dynamic extent of the object, not just here. What that means is that when I can temporarily change the value for a global, not just here, but everywhere, right? And then it goes back to the value once I leave the scope where I am binding the dynamic extent indefinite scope object. So the global. So there you go. So show me says 10, right? Then we go ahead and we shadow it out with right. We go to 5, and then it goes show me again, right? He says, and basically it says it's 5 now because that's what exists temporarily, and then show me again, and all of a sudden when we left the scope of the let, the shadow disappears. It's not, of course, not exactly a shadow, but like a shadow disappears, and the global goes back to its original value of 10, right? So if we go ahead and test it, right, I put it there in things, evaluate it all, and you see, all right, global 10, then 5, then 10, and there you go. Okay, very simple. It's actually very, very cool, very neat way to sort of have kind of like an out-of-band instructions to your functions, right? So that's a pretty cool idea. The idea that you can actually have like a second pipeline of information, sitting in your program that you can essentially play with and modify. And perhaps that's where a def parameter came from, like parameters that you can modify of your actual software. Because these global variables, you can change and play with them, right? And they essentially will affect the entire software because the functions will see the specific environment that you wish, the parameters, the way they should be at the moment. Right, so that's it's pretty neat and pretty cool idea, right? And again, it's really cool when you start mixing in threads as well. All right, but again, for the moment though, just on the basic level, that's what's going on there, and that's what dynamic extent feeds into there. So the technical language, a reference by name to an entity with dynamic extent, right? So basically, I have a name bound to some dynamic extent object. Will always refer to the entity of that name that has been most recently established. Right, so meaning that even though it's someplace else that G is being used, it's going to equal whatever the currently established, binding is between the star G, the earmuffs G, and again whatever value, whatever object it's that basically we're going to be looking at the time. Okay, so that basically explains that. So again, that for the most part, that's what I'm doing for scope and extent.